So this is continuing on topic 6. We've got mechanical energy, and we talked about that at the very first here. But mechanical energy, as noted earlier, represents the combination of kinetic and gravitational potential energy that's possessed by an object. So this formula is what they give us for mechanical energy, and that's basically just telling us that when you have kinetic energy plus potential energy, that is the total is mechanical. And they're basically totally relate to each other. So if we were going to have more potential energy, then we would have to have less kinetic, and vice versa, because they sort of add up to each other to make our mechanical energy. Okay? So it says, what happens to the kinetic energy of an object as the gravitational increases? I just said that. So as your gravitational energy, which is your potential, increases, then this one would have to go down to keep this number the same. And if that doesn't make sense, me doing it that way, if I give it a number, so let's say this is 10 joules of energy, and we've got 5 of kinetic and 5 of potential. And if we're talking about this potential going up, then we could maybe change it to 8. Okay? So if that one changes to 8, then in order to keep that 10 joules, which I'm just making this up, but in order to keep that, this one would have to go to 2, right? So whenever we change one, the other one will, go up or down depending on if we're, having more or less, increasing or decreasing. And what happens to the gravitational potential energy of an object as the kinetic increases? Well, the exact same thing. So when our potential or our kinetic energy goes up, then this one would go down. Okay? So they're totally related to each other, and they really affect one another. Because if your energy is always the same, it's just changing between those two. Your energy is potential or it is kinetic. So it's one or the other. We're not losing any of our energy. And this makes sense when we look at this picture where our potential energy at the very top of the hill at A is really, really high, because we are right at the point where we are going to possibly drop. And our kinetic energy is low, because when you're at the top of that curve, you're not really moving very fast. As the cart goes down the hill, then its kinetic energy will start to go up, right? So as it's going down here, this kinetic energy is going to go up, which means its potential is going to go down. So when we look at this, potential energy is pretty low at the bottom, but our kinetic energy is pretty high. And that's sort of how that works, so that relationship between potential and kinetic. So this gives us an example, and I will write stuff down as we read through. It says a 0.300 kilogram baseball, so it's mass. Is thrown in a straight line through the air at a height of 2.5 meters high. So height 2.5 meters high. Above the surface of the earth. The ball has a speed of 20 meters per second. So a speed would be a velocity. What is the total mechanical energy of the baseball at this height? So it wants us to find its mechanical energy. Okay. So the first thing that we should note is that we know what the formula is. EM is equal to EK plus E. Did I say EP? Because it's potential. And we have some information to, figure out both of those things. We have the information to figure out our EK. That's 1/2 mv squared. And we've got an m and a v there, so we can actually figure that out. We also have the information to figure out our potential energy, or EG. That's mgh. So we've got a mass, we've got a height, And we always know what gravity is, so we can actually figure both of those out. To figure out our EK, it's 1/2 our mass, which is 0.3, multiplied by our velocity squared. And then for our other one, EG is equal to our mass, which is 0.3, times gravity, which is 9.81, multiplied by, maybe I don't have enough room here. Why am I not writing anymore? Our height, which is 2.5 meters. Just gonna write it like that. So we just gotta do these out on our calculator to calculate, basically. I'm gonna do the gravitational potential just because I only have my phone with me. So we just need to multiply across, and we get an answer of 7.3575. That's joules. We don't want to round our answer yet because we're not done. I didn't want to get rid of that, but... And then if we do this one out on the other side, 20 times 20 is 400 times 0.3 times 0.5 gives me 60. All right, so now we just need to use the formula EM is equal to EK plus EP. So our EK is 60 plus our EP, which is our gravitational, 7.3575 joules. So if we add those together, I don't know why I was going for a calculator. What is happening? We get 67.3575. And if we look back at our question, we want to round that to one significant digit, because 20, oh no, sorry. I didn't write it down. We got 3, 3, and 3. So our answer can be to 3, which means it's going to be 67.4, and that's joules. Okay? So that is our final answer. That is how we would figure that out, and that's our mechanical energy. Okay. So that's that. Our last part here is talking about the law of conservation of energy. It says, although kinetic and gravitational potential energy possessed by an object may change depending on the situation, the total amount of energy possessed by that object remain constant. So this equilibrium, state of EP and EK is referred to as the law of conservation of energy. So it says, note that the law of conservation of energy is essentially an implication of the first law of thermodynamics. Energy cannot be created or destroyed. So when we look at this formula, basically what they're trying to tell us here is that our EK and our EP, they coincide with each other. They're in some ways equal to each other, because if one thing has nothing, then the other one gains it all. And we talked about that already. So in some of the questions that you might have where you don't actually have one or the other, you can use that, use one or the other. So basically what I'm trying to say here is that your EK can in some ways be equal to, okay? There's a video there you can watch, and then there's some examples here. So let's try, I'll do number 1 at the top here. It says a 1.5 kilogram rock, so that's a mass, is dropped over the edge of a cliff 30 meters above the surface of the lake. What is the speed of the rock just before it strikes the surface of the lake? So we're looking for our velocity. We've got a height and we've got a mass. So this is asking us for a velocity. If we think back, our velocity questions use EK is equal to 1/2 mv squared. We don't have EK, we don't have velocity, so we can't use that formula. The formula we can use is EG is equal to mgh. Because we've got an m and we've got an h, so we can actually figure out our EG. So I'm gonna do that. So if we calculate that, I just plugged in the pieces of information into the formula. And if I can put in my calculator properly. I get an answer of 441.45. That's joules. We don't want to, round it because we're not done this question. That's our EG. Then when we're doing this, we should say that our EG, I guess, in this case, can be equal to our EK. So if our EK is 441.45, we can use that to calculate using the formula EK 1/2 mv squared, the one that I have at the top here. But I'm just gonna rearrange that equation so that we got V by itself. I'm only gonna erase that just for space-wise. So we're trying to figure out velocity. It's gonna be the square root of 2EK divided by m, I believe. So if we calculate that, 2 times 441.45 divided by our mass, which is 1.5. Just gotta do this out of my calculator. I get an answer of 24.26. That's a velocity, so it's in meters per second. And just to reiterate or go back to the question, we really should be rounding that to 3 significant digits. So I'm going to round this. So it was 2.6. That 6 makes the 2 become a 3. So that would be our answer. All right. I can try the next one, I guess. It says a 10-kilogram water balloon is dropped from the height. So I'm gonna just, as I go through this, pick out pieces. That's in mass. And it's dropped from a height, that's an h. Calculate the speed. So again, this is a velocity. That's using the exact same formula we just did. So I'm not gonna do that one because it's literally exactly the same as this question. So we'll try doing the last one here. So it says a 30-kilogram child, that's a mass, jumps on a trampoline vertically, has an initial speed of 1.6 meters per second. So that's a velocity. Calculate how high. So we're looking for an h. So I'm just gonna write that stuff down. We got 30 kg child. We've got a velocity of 1.60. We're gonna use the formula EK is equal to 1/2 mv squared so that we can calculate our EK. And then in doing that, we'll take EK is equal to EG. Plug that EG in, whatever we figured out, and use the formula H is equal to EG divided by mg. And then we'll get our answer. So I'm just going to plug this in over here. Sorry, I've got 1/2 mv. Our m is 30. And our velocity is 1.6. That's squared. So we want to go 30 multiplied by, no, we don't want to because I don't have the right calculator. Squared multiplied by 30 multiplied by 0.5 gives us, I got an answer of 38.4. So that's for our EK, that's a joule amount. I'm going to use that in the place of EG in the formula there. So when I try and figure out the height, I'm going to use 38.4 joules divided by my mass, which is 30, multiplied by my gravity, which is 9.81. And figuring that out, it should give me my answer for the height of the child above the ground on the trampoline. So I just need to $294.3. This doesn't look like the child is very high off the ground. Did I do this right? I got an answer of 0.13. We need 3 significant digits. Yep. So this would be meters. So I'm saying that's not very much. It's like they went 13 centimeters off of the trampoline. I guess they didn't rise up very high, but I guess that's, we don't know how their jumping is. Anyway, I'm gonna guess that that's probably right, but not very high off the trampoline that they were jumping. They are a child as well, and they don't weigh a significant amount. All right, so that's how we do that. What you need to remember here is that EK and EG, they can be interchangeable in these times where we don't have the proper information, I guess, to be able to figure out the rest. All right, so that is topic 6, and that's the end of our physics unit.